And Sharon, Sharon, you can go ahead.
Diana. First of all, I want to thank you all for joining our session on generative AI and large language models today. We have with us our key speaker, George Roth. George, on behalf of the Americas Community, Denver chapter, and SoCal chapter, I want to thank you for accepting our invitation to join in as a key speaker. Your thought leadership and your visionary has impacted UiPath, especially in document understanding. And I'm very excited, I know most of you are, to have you in this session and gain insight on what you will be presenting today. I just want to mention to the audience that if you have any questions, please write it down in the chat so George, Russell, and I can answer it for you. Thank you once again for being here, George, and I'll hand over the floor to you.
Thank you very much, Sharon, for the very nice introduction. This is one of the nicest places to speak. I mean, UiPath could not exist without this community of fantastic people. I had the chance to meet many of them and many of you. And it's really amazing because you are really the practitioners, and we get the feedback from you. You are our sensors in the real market. And this will be a session which hopefully you will ask me questions, and me and Sharon and Russell, who are extremely knowledgeable about this. And I will want to go over not only about what UiPath does, to give you an idea about the overall things which are going on in the world related to AI, and also to open some, let's say, path for you to go and explore further. It was so beautiful to see before our community hackathon. I had a meeting and we talked about some technologies, and after the hackathon, we saw implemented many beautiful things, and we will see today some samples of the results of that. So let's start about these things. So everybody talks about these new things like large language model, foundational models, AI-driven chatbots, fine-tuning, generative AI. So what this is really so special, what is so special about this? And people are talking about this revolution, which is equivalent with the apparition of the internet. Well, large language models existed for a very long time. When we got ChatGPT, like the OpenAI Christmas gift, was a great marketing move because they launched it before the Christmas last year. Of course, Microsoft had a big thing into it. And they offered a sample of what can you do with this. It was like a big surprise. So the large language models are, what is so special about them? Well, people who are like myself, who worked in the previous generation of natural language processing, they know that before we worked with languages, a lot of linguists were involved in studying natural language processing. What is the difference here? It totally disappeared, the requirement to have linguists into this, because what happened, somebody had an idea a long time ago to basically convert all the text in some numbers. The computers don't speak languages. The computers know to understand 0 and 1s. They understand numbers. So the idea was to basically convert everything in numbers and use very sophisticated digital technologies do certain thing with numbers and bring back the results in languages. So the humans can talk using regular human language in any language and talk to the machine, which talks its own language, which are the numbers language. And that's why these LLMs are large language models are working digital. Everything, I'll show you in a second what that means. And also they have an interesting property. They can basically, if you give a text, they can predict what would be the next word, which would follow logically in that text. So many of these models appear. Now, there is usually a confusion between foundational models and LLMs. The big difference between the two is that foundational model is much larger, and foundational model does not talk only about text. Foundational model includes images and something like it's called multimodal, sounds, and everything else goes in these foundational models. And foundational model terminology was introduced at HAI Institute in Stanford. And basically their idea, the name, comes from the fact that when you build a house, you have a foundation. And this foundation is basically, on this foundation, you have to build your rooms. You organize your rooms based on your own needs. You have to see what functionality you expect from a house or from an office or from a building in general. So that's why a foundational model as is has to be considered something that you can build on and bring it close to what your requirements and what your needs are. And that's why also I heard the presentation, somebody said like foundational models are like the common sense. So for example, I give you an example, we talk about summarization. No? Summarization is not specific to a certain information. It's not specific to a certain domain. How to read something and to summarize the main ideas has nothing to do with what domain is that about. It's more like a technique that you learn after you read a lot. But you can summarize something which is incorrect also. And this is, for example, a functionality to summarize. It's offered by foundational models and LLMs, because have nothing to do with the content of the information. It has to do with something which is the common sense. So that's how you have to take these foundational models. Then the chatbots has to change completely. The chatbot is basically what? It's a delivery mechanism of an interaction with one of these foundational / LLM. No, because you can talk to them, and this is the chatbot. And now you will see there is this convergence between chatbots and avatars, and all this concept of metaverse. This will be very much influenced by all these LLMs and foundational models. Then it came this idea about fine-tuning. Fine-tuning means that, let's assume OpenAI read the internet from 2000, up to 2019, I think, or 3 years ago, the GPT-3. And then the information on the internet, you find everything, starting with garbage, find publications, academic publications, you have stupid information put by all kinds of people. And you have no guarantee that what you read on the internet is something real and something which is true. So that's why taking a model like this, also you know about everything on the internet, but you don't know specific things, no? And that's why this concept of fine-tuning came. And in the first month, after the OpenAI came, everybody talked about, yes, fine-tuning has two main parts. So actually has to use an LLM, a foundation model, and bring it to your needs, you have to do two things. To do fine-tuning, that means that you have to teach the system more things that you are important to you. And also it's a phase of distillation. That means that you have to reduce the size of these huge models that were built, because I always bring this example like the Encyclopedia Britannica, that we, before the computers, Encyclopedia Britannica was all this, have an image of hundreds of books. But when you look for something, you don't need to know all the books there. You pick a book and you look from it, which is your interest. And this is the same fine-tuning. You don't need to work with these huge models. And for example, if I want to find out what was the temperature yesterday in Los Angeles during the storm, I don't have to go to LLM to find that in. I have a website where I can ask very easy to find out what's going on. So these are the things which, one second. The interesting thing is how David Barber, I don't know if you heard about him. If you didn't, I highly suggest to do a search and look for him. He is from the University College of London. He is a distinguished software engineer at UiPath, or researcher. He basically came on board with the acquisition of Reinfer, which is communications mining right now. And he is one of the pioneers of LLMs and of active learning. We will talk about this. And he says, and if you are looking for him, he is known in the world as the author of one of the most difficult machine learning books for students. But his books are really amazing. And he says that Arthur Clarke was a famous author of science fiction, and he said that any sufficiently advanced technology is indistinguishable from magic. So this is true, because when you start talking to ChatGPT, you just get amazed of, oh, wow, it can write me a nice letter for my friend. It can convert an article from a language in Chinese in Shakespeare's language with no problem. So you get just, you don't understand. It's very similar with magic. To come back a little bit about this, how the text ends up in numbers, and why is this so odd that nobody really understands really what's going on. So this concept of embeddings means that if you have a word, you start associating some numbers. You don't try to understand what those numbers mean. Nobody really understands what those numbers mean, but there are different techniques. And not two numbers like in this example, but in some, there are thousands of numbers associated with the word, or can be a sentence, or can be a paragraph, depends how you split up your text. And the idea is, so if you have, if this is in 2D, we have here only two numbers associated with a number. The whole problem is, if you get the word apple, where will you place it on that grid? And you definitely, you put it in around the fruits. No, and then if you start finding, you put the word apple in a sentence and you ask, what is an apple? It will tell you apple is a fruit, because it's in the region on your graph which is associated with fruits. And all this technique obviously requires a huge computing power. Think about, if you have one word here with 1024 numbers associated with it, so it's a space not with two dimensions how you see here. There are 1024, you cannot imagine that. And then you need huge computer powers. That's why all the big companies, the cloud companies who have these GPUs and all these TPUs and these super powerful computing power, they love AI. They love to give you tools of AI because you will use their resources, and all the cloud companies are working like the cab, like Uber. No, they want the only thing is to use my computers, use and pay me by the time and the level of resources that I use. So that's why behind these companies there are these companies who offer you all these resources, because it's very important to be able to calculate this in a reasonable time, to have this huge computing power. And here you'll see on the right-hand side, it's another example where in this case, the matrix is not for words, the matrix is associated with a sentence. And you can see how if you give these numbers, which are called embeddings, to these numbers, and you have a huge database, which contains this, when you have the query, what is the capital of Canada, they will find on this space of numbers the fact that this sentence, this question, what is the capital of Canada, will be close to a sentence which tells you the capital of Canada is Ottawa. And that will be much further of something which tells you that the capital of France is Paris. So we'll not give you the answer of Paris. So why I brought this in, it's just to tell you that this is so sophisticated and people don't have to start thinking about what these numbers mean. If you start thinking philosophically, for me, is still an enigma. The fact that if you have text in certain language, I can do stuff with numbers, and the numbers have no clue. The computers have no clue what I am talking about. The same numbers are for images. The same numbers are for EKGs in medical and for text. So, but the methods are the same. And that's why this is the technology that nobody really understands how it works. That's another David Barber sentence. Another interesting thing that Yuval Harari said, which they all know who you are, it is actually the first technology in the human history that can make a decision, and it can be creative too. Another big thing, it hallucinates, which means that this technology, I call it like a bad car salesman. So if you ask a car salesman, is my car better than a Ferrari when I go up on the mountains in Lake Tahoe? They will say, of course it's good, and is much better because the oxygen quantity in the engine is done and so, which is totally not true, but it absolutely makes a lot of sense. And that is the hallucination. So it makes up responses that seem real, but they are not. Another interesting thing is, and this has an impact on humans, so this technology knows everything. So if I read all the internet, I know all the domain. It doesn't matter if it is nuclear physics, or it's mathematics, or it's Chinese culture. For me, because they read this internet in months and months, they spent a lot of computing power, and they emitted a lot of CO2 in the atmosphere in order to put all this information in one place where the humans talk. So if I am a physicist and I talk to a person who is expert in languages, I don't know all the theory of the grammar and the stuff that the other person, or the history of literature. I don't have the same level of knowledge. These systems can store everything, so then they store fast. That's why they beat the computer in many things, like in chess, because they have all the combinations possible. They know everything, or in Go too. So that's interesting, when they beat in Jeopardy, the computer beat the humans, the interesting thing they said, scientists said, yeah, it won against the human, but the problem is that the computer doesn't know it won. So another interesting thing, it's allows mass customization. And this is Daniel Susskind. We'll come back to him at Oxford University. If you look at the recordings from the AI conference in together in London, he had a very nice speech there. So you can do mass customization in the sense that if I tell the computer information about somebody or a system, the computer can talk to me in a way to be customized based on the context of the subject of the discussion. So if you have a person let's talk about Salesforce, you have a person, you have a lot of information about that person, you read a lot of emails. When I respond to this person, I can respond not with the template, how the old system did that, you got these boring emails. You can put some stuff there that makes the actually very hard to distinguish that it was generated by a human or a computer, and this has other implications. Here it's very short. It's basically, never forget that these are super expensive technologies. So I will very exaggerated stuff. Actually, an inference, it's a query, if you want, that's called inference here. But the point is, if I want to find out what was the temperature in LA yesterday during the storm, I will not go to an LLM. I will do a regular query, because I still have databases. The databases will be there with structured data. I have the whole thing in an enterprise, all these databases, which data is very exact and very good. So the key is to basically know how to combine what you have in your databases in classical structures and all these other techniques, all this other information which exists in these LLMs or in the multimodal foundational models, and how to combine these two, because it's much cheaper to query a database than to start looking in an LLM. We talked about this. There is a big difference between the consumer and generative AI and enterprise generative AI. First of all, remember, you cannot use in an enterprise open AI. You cannot, because first of all, you don't have a guarantee that the responses are right. And also you have to be very, the requirement of the enterprise are much more strict than for somebody who plays to write letters and summarize stuff. So it's always, you will have to have some enterprise grade system, and we'll address this in a second. So a thing that you are hearing a lot, and we'll come back to this, is this trustworthy and responsible AI. Because this system hallucinates, then you have to make sure that when you you try to use this system to help you in a decision, for example, it helps you in a diagnosis, you don't accept that just the system makes up something about this. And that's why the human in the loop is essential in looking at the veracity and the validation of the results. Also, you have to be very, very careful about privacy, because entering data in OpenAI, you will not have the guarantee that that system will not end up somewhere else. Also, intellectual property, it's a big thing. And then it's a huge thing, the responsible AI. So at the first ChatGPT, if you ask a question and you said, give me how to manufacture a Molotov cocktail, the response was step one, do this, step one, do this, the step two, do this, step three, do this. At the end, it published there, but watch out because this is illegal in certain countries. Well, that's very nice, but now you want to prevent the system to give you information which can be harmful for certain people. And that's why it's called responsible AI. And there are a lot of efforts, but we'll come back to this. So trustworthy and responsible AI are absolutely important. The fair and impartial. I just tell you one word here, bias. Now, one of the big things people talk about, make sure your system is not biased. And I give you an example which wasn't so dangerous, but I visited a friend of mine who was doing multimodal machine learning on Stanford, at the Stanford hospital. They were building these multimodal models for prostate cancer study. So they put together X-rays with CT scans, together with MRIs, together with biopsy results, lab results, so data of different types. And they try to enhance the diagnosis and also to verify the diagnosis and offer the best therapy. And they were talking about how to extend this to other hospitals. And they realized that their system is very biased because most of the people who are going to the Stanford hospital are very rich. I mean, not everybody has access to the Stanford hospital. And that means that all the results where all these, especially in studying cancer and this stuff, it's a system disease. It's an ecosystem of facts which influence your problems. They cannot use this without doing, because their data is biased by the fact that the level of the alimentation and the environment where these people comes from a very affluent area. So they didn't study with populations in a less affluent area or another country in order to generalize. So that's bias. As a example of using of these technologies, I will show you this is our platform which has the three parts. We discover all the things, and then we give you, we offer, it's an AI-powered automation platform. We in the discovery phase, we use AI in our process mining, task mining, communications mining. In the automation, we offer different packages of products in order to implement the automation. We offer tools to operate, and then we basically offer all the infrastructure to run this. And AI is everywhere into this. And as a first example, which was in our agenda, is to see how two systems work together. And this is the UiPath communications mining, which it's a system which was a result of an acquisition of Reinfer from London. They have an LLM. They have a specific LLM, and you have the UiPath document understanding, which I actually came to UiPath through the acquisition 5 years ago. It was our platform, which was this document understanding. It took 4 years to become the best in the world in documents, and structured and semi-structured. But these two products, they use LLMs, generative AI, and we'll go over a little bit. And in order to do this, I have actually a little demo that I will want to show you. Hold on.
Hello everyone, my name is Mike Robinson, and today we'll be looking at communication understanding and automation using UiPath Communications Mining. Today, organizations around the globe, small and big, share a similar challenge. They receive a massive amount of customer communications through channels such as email and chat that require quick and accurate responses. In this demo, we will be taking a look at a real customer scenario related to policy renewals at an insurance company. This process was completely manual before and took 3 days and spanned across multiple people in the business. With UiPath, the underwriters now have to process only exceptions, while the robots automate the process. They reduce the time to process each request from 3 days to 3 hours, improving organizational efficiency and, more importantly, improving customer experience. Now, let's see how UiPath are able to help customers achieve these results. As a business SME at a typical insurance company, I can see that communications mining has analysed the historical data and extracted the intent and topic of the emails. I can understand what's driving the volumes and use this data to identify high volume and high impact processes to be automated in this mailbox. I can see a significant number of these processes are transactional by filtering for the email threads that have 2 emails or less, and I can see that the volume is being driven by policy-related requests, and more specifically, policy renewal. Switching over to the trends view, I can filter to focus on policy renewal requests, and I can see that we have a constant inbound of renewal requests and a peak of at least once a month. By double-clicking on this data point, I can see the underlying messages that are driving these volumes. Here, I can see the predictions communications mining has made. Communications mining understands these emails are related to renewals and extracts relevant information with high confidence.
So what I want to say, so what communication mining does, basically looks at your emails and they classify these emails using their own LLM. So that means you don't have to train at all. If you upload a set of emails, then immediately the system will give you, if you remember my matrix there with the numbers and how they put them in different areas, the similar thing, they come out with something like that from the beginning. So they have their LLM. And from each email, they extract a few things. They extract the intent, which are those terms that you saw, for example, address change in a bank, or these things related to the processing of a claim. And then they determine that this is an address change request. Also, if the email has certain data in it, which is used in generating a transaction, the objective is to take the intent of the customer and actually generate transactions to replace the human intervention there. And if you have like a claim processing, you have documents, you will use document understanding to extract these things.
Communications mining is to different concepts. And communications mining shows us how often we get the prediction right and how many emails will be left for manual processing. This label is performing well, so our client knew that it could expect end-to-end automation for the vast majority of renewal requests they received. Now, let's watch the robot process several emails. The first email is a renewal request, and in the background, the robot extracts and validates the policy number and email address against the CRM, creates a renewal contract, and sends this contract to the customer. The robot has identified the next email as a quote and moves the email to the quote folder for the team to process. The next email is a renewal request. The robot goes through the same process as the initial renewal request that we saw, but the email address to the sender does not match the email in the CRM. So the robot has created a task for an underwriter to process. Let's take a look at that task. As an underwriter, I can immediately see that this is a request related to policy renewals. I can also see that communications mining extracted information like policy number and effective date.
So this is the human in the loop, in the fact that after you do something, before you basically send it out, you basically have a human to review, and these are so-called guardrails. You don't let the system and LLMs to make decisions in a way that you do transactions without a human reviewing them.
It seems that the robot has found the policy in the CRM, but the reason for an exception is an email ID mismatch. I can validate this information and have the robot generate and send the contract to the customer. Once the task is submitted, the robot creates the renewal contract and sends it via email. The robot moves to the next email, and this email is classified as a claim. The robot downloads the attachment and uses UiPath Document Understanding and Forms AI to extract the relevant information from the claim attachment.
So I will not go further. You will have access to this. You can see this. I just wanted to show you basically how the two here in the UiPath communication mining knows how to use emails. Using an LLM classifies them. And there is a process of active learning, it's called, which is used in order to refine. So the LLM is generic. But if you want to work in insurance, the SMEs are using this system and each time are reviewing what the system suggests, what communications mining suggests, and in this way are building the labels for different actions that will be taken based on the emails in an interactive way. And this is called active learning. It's equivalent of fine-tuning that we are talking about. Now, the document understanding, where is generative AI used here? Well, in UiPath communications mining, you can use in the communication, as we discussed, we can have customized communications. UiPath document understanding is using generative AI in the labeling process. If you know document understanding, you have to train the system for a new document. We have a demo for it too, but I don't want to go through the demo. You can see it. So basically, you put a new document, ChatGPT type of system will tell you what type of label is that to extract the data. And then definitely UiPath document understanding has also classification based on ChatGPT. So generative AI, it's included in com mining, LLMs, and fine-tuning through active learning, and UiPath document understanding, which, by the way, will use active learning too. So the experience of these two products will be totally the same. I will now I want to talk a little bit about Trustworthy AI. This is a professor from Berkeley, and basically it said, where are the risks of this generative AI? Bias. So bias is what I explained to you, and in communications mining, for example, the system tells you that a certain label, let's say, if you study the emails which are complaining about a product, and somebody says, oh, this is, you know how they do when you have a good restaurant, they ask your friends to say, oh, this is a fantastic restaurant. If you put 10 people to say that, then you want that everybody will see that your restaurant is fantastic. So they detect this, and that's a bias because you didn't train the system enough. And it's beautiful in communications mining. It detects the bias and also tells you what to do, where to train more the system and how to train it in order to eliminate. So here is the bias manipulation. You see, all of you, you can see how, especially now in politics, how this is used, generative AI is used. You have disinformation and these deep fakes. So you see all these people who talk like a celebrity and they are created by the computer. And definitely you have a lot of potential impact on employment. it's very it's a problem that has to dealt with. We'll deal with, and I'll tell you how to do. So the idea, I put this information here to see that all over the world there is an effort to create a policy, and probably the result will be the creation of an institute which will be equivalent to International Atomic Agency. From our platform, you can see AI is everywhere, and we have these two types of AI. Generative AI are the foundational models that we, with the new component, which will be delivered now, and I think it's already the LLM gateway, you will be able to access all these generative models. And then we have this specialized AI, which is can be a fine-tuned model, LLM, or something else, which is used to solve different problems, and the solutions are packaged. And down here is the infrastructure, which is super important: integration service, validation station, active learning, fine-tuning, guardrails, auditing. These are all essential. Fine-tuning, active learning is fine-tuning. The guardrails are these controls that you put there. I can tell you there are companies right now like Arthur or another one, Galileo, who created these guardrails in the sense to prevent false information generated by an AI model. They call it like the hallucination firewall. And they create this type of tools which helps you to determine if the system does something which is not true. Obviously, we offer access to OpenAI, Microsoft, all the big models through this LLM gateway. Our platform, it is open. That means that we can we allow the people to use all the big models, the foundational models. Flexible orchestration allows to combine multiple types of AI in solving a certain problem. And obvious, the responsible AI, it is how you offer guardrails, you offer detection of bias, and many other things in order to make sure that the AI is not used in a harmful way. There is work going on right now that we will offer the clients the potential to basically disable the use of LLMs in the products, because document understanding, com mining, and others are using LLMs, and the clients will have the possibility to disable the use, and also to be able to disable, to basically not allow the usage of your data in training of the machine learning models. If you know, it recently was a big scandal with actually Zoom about this. Now, the last part that I want to mention is this personal intelligent assistants. And what I want to tell you here, something interesting. So everybody's afraid that AI will replace now the white-collar jobs, this generative AI. And this is actually from Professor Daniel Susskind. If you look at the current state of the science of AI, from the white-collar jobs, you could completely automate 5% of the white-collar jobs. So that's pretty small percentage. But if you take the approach bottom-up, and you look at all the tasks that people are doing right now, the white-collar jobs. So, for example, a person who does accounting has all the time to look at invoices, or a person who is a researcher has to do a derivative, solve a complex derivative in something. So if you look at the tasks, 65% of these tasks can be automated. So the result of this is that intelligent assistants, which are specific to a certain job, are the way to go, the future to go. And the LLMs that we talk about, it will be smaller LLMs, which are specific to a job, and it will be built in time. And to give you an example, I took these guys, it's a company based in Singapore, who basically won the hyper hack with a beautiful application of an intelligent assistant for doctors, and which helps basically the doctors in order to offer the best service to the customers. And you will see an intelligent assistant has a voice-to-text conversion, summarize conversation, augment with other information, so multimodal AI that we talked about, that they combine all kinds of lab reports, medical imaging, and all these things in this interaction between the doctor and the patient, and then generates a recommendation using the patient checklist and medication. It's emailed on the spot. I have a demo for this, but I want to mention another. It was the third place in our hyper hack. This lady from Turkey created a similar application, intelligent assistant, which basically combined two things. She combined actually created an intelligent assistant for a patient who wants to find out information about medicines. You can take a picture basically of you can take a picture of a box of medicines that you have, and the system will tell you what are the problems with it and how can interact with other things that you take or with your personal problems. And at the same time, it helps the doctor. So there are two intelligent assistants, one for the patient and one for the doctor. Now, the idea of I will finish with showing you the demo, but the idea is the intelligent assistants are basically, in my opinion, a big area of development of the future, when you will start with a small LLM, which can be pre-trained, for example, for a doctor or anything else, and then you let the activity through to be the doctor to train this in the future, and also to do and automate the tasks, which are very time costly. If you think about, don't forget the bottom-up approach, 65% of the tasks can be automated. So you start automating those tasks, like in this case, you see summarization and augmentation with other stuff, and also generate reports and so on. So before looking at the time, we have 8 more minutes left. I don't know if I have time to show you this demo. I'll start it, but I'll stop in a few minutes. I don't let it the whole thing to do.
Hi, we are Team Dr. Simplify, and our use case looks at leveraging the capabilities of both specialized and Gen AI and bringing their combined power to solve a very real use case in healthcare that has been faced by pretty much any patient who has visited a GP or a specialist. So let's get into the solution. Here it is. Like any solution, it gives you two options. You can either create a new patient, which will be used by the receptionist if the patient hasn't visited before, or find patient, which is what's going to be used by the doctor. In this case, we're going to search for the patient using email, but we could do it using NRIC, the Singapore ID, or phone number. This brings the doctor to a very intuitive user interface. And let me first click on Start Recording and tell you what's happening behind the scenes. The conversation is now being recorded between the doctor and the patient. Behind the scenes, we're using Microsoft Dictate for this for two reasons. The first one is Microsoft Dictate is very good at differentiating conversations between two people or multiple people. Number two, we found it to be very accurate in the recording itself. Once the conversation is done, the doctor clicks on stop recording. You'll see that the conversation that has been had between the patient and the doctor is captured under the conversation tab. This also fires a robot that will take the conversation, make a call to ChatGPT, and then generate a summary of the conversation. As you can see, that has just been generated. If the doctor feels that the conversation is not accurately captured, the doctor can edit the conversation. They can do that for the summary as well. But in this case, let's say that the doctor updates that the patient never had chickenpox before, which was missed by Microsoft Dictate. This automatically fires a call to ChatGPT to update the summary based on the updated conversation. And now notice under the summary tab, the last line, which is the patient has never had chickenpox before, has also been captured in the summary. With summary all set, the doctor then uploads any lab reports and diagnostic scans that the patient may have had or brought with them. When the doctor clicks on send, the 2 lab reports and then the 2 diagnostic scans are uploaded into orchestrator storage buckets. This will be used in the next stage of the process. So now the doctor has all of his or her inputs. They go ahead and click on evaluate. This does 3 things. It takes the conversation summary and makes a call to ChatGPT to get the findings based on the summary. For lab reports, it uses DU to OCR the lab reports and send that text to ChatGPT once again to get the findings based on that. And for diagnostic scans, it makes a call to a model called Biomed Clip to get the findings based on the diagnostic scans, takes the text, sends it to ChatGPT to get it back in an NLP form. And once that's all completed, ChatGPT, based on our prompt, returns the top 5 possible illnesses based on all of the findings, right?
So I'm sorry I had to talk, but if you will want to see more, definitely you'll be able to see this thing. And we can connect you with the team of Simplify AI, and also with the lady from Turkey. We'll show you the application and give you more information the way how they did. I think it's a beautiful application. So that was a little bit, it was really fast, a lot of information. I didn't have a chance to look at basically at the questions. So I'll thank you very much. And I apologize. The speed was too much, maybe, but I would consider this as an opening of dialogue, and you can contact me anytime with any question. I don't know what questions we have. I see we have a lot of questions, I guess.
Thank you, George, for a wonderful presentation. This was incredible to learn about how you can harness the power of large language models. To the audience, if you have any questions, please feel free to add it on the chat, or you can simply unmute and ask George and the team your questions.
I am looking here. Yeah, I don't know. I don't. Do we have separate questions? I'm looking at the chat. There are any questions here?
It looks like Russell and Sharon answered most of them.
Ah, cool.
Yeah.
Excellent.
Yeah. Is there anything, Russell or Sharon, that might need an answer from George?
Yeah, I would like to reiterate one of the questions that were asked in the chat and just get your opinion, George. This had a lot of thumbs up, so I'll present it to you.
Okay.
So Vincent says, my company's cybersecurity group tests employees randomly by sending simulated phishing email. We get dinged if we've opened a number of those, and in the past, we have had to go through training on phishing. Would communications mining blindly open emails like this as part of its classification scheme?
This is a fantastic question. I am not. I don't know if the mining team did something like this, but it is a fantastic. Definitely, if the LLM, you can create a label which would be phishing. And then that would be how in the active learning, which is an SME, which will see these and will mark it as phishing label on it. Definitely more you use it and more will be detected, the model will determine those, because it's an LLM which is trained, and the phishing will be an overwrite of a normal classification that would get. But I think it's a fantastic thing. I will promise to ask this, the combining team, and I think you will have somebody from combining tomorrow or after tomorrow. But by tomorrow, I'll find out the answer and I will communicate to Diana and to communicate the answer to this, because it's a fantastic question.
Thank you very much, George. Vincent, if you will be attending our session tomorrow, we can let you know on our second session. Will that be okay?
It'll be just fine. I will be there.
Okay, perfect. Thank you,
Thank
George.
you.
Thank you, Vincent. George, we have one more question by Miguel. Miguel says, can you give us an advance of what a vectorized database is and how can it be used?
Database. Yeah, great question. So there are, if you follow me on LinkedIn, I had a post about vector databases. So vector databases, well, we had SQL databases. Now they were specialized in doing table data. A vector database has super performant techniques to deal with the embeddings. And to take, like, if you put a query, generate that number, and it returns you exactly the answer because it knows how to go through these vectors and find out the closest vector to your question. And that's the genesis of the answer. So the vector databases are the most specialized databases to deal with embeddings in all these huge vectors of numbers which are converting text in numbers. But again, if you look at my postings on LinkedIn, it's a whole article about an overview of what is available. From the old databases, the people who are my age who work with Postgres has a whole vector to it, but there are a lot of open source databases used for these embeddings.
Thank you so much, George. Does anybody else have any questions? I know we are at time here, but if you have any questions, feel free to ask George right now. Cool. In that case, thank you so much, George, on behalf of the community for joining today. Today was a very special event and was a success thanks to you. I hope the audience gained useful information and insights with our session, and we hope to see you in our continuous sessions tomorrow and day after. Thank you, George, and thank you, everybody, and hope you have a good rest of your day.
Thank you for coming.
Thank you, everybody.
Bye.
Thank you, everyone.
Thank you. Bye.